And welcome back. And now we're looking on page number 148 at the parts of a circuit. This is also a review. I really like the diagram they have right here. We already know that the energy source right here is also called a battery. Batteries keep the current flowing. You know that a circuit has to have wires going from the battery, from the energy source over to a resistor. The resistor here is the light bulb. Remember, it said the resistors have materials that slow down the electrical energy, and that causes it to transform into another form of energy, giving off light energy. Here's another wire coming over to the switch. That's right. The switch is right now in the closed position, making it a closed circuit. If we open the switch, then the circuit would be an open circuit, meaning it would not work. And you can see inside the wire, because the wire actually has a rubber coating on the outside making it an insulator, but inside the wire there is a conductor. There's metal, because we have to have metal to metal to metal to metal to metal. Here's a circuit diagram. If I can get my page to come over. There it goes. They're using this right here. Here's the key for a diagram right here. A straight line is the wire with two interruptions, a long and a small. It represents a battery right here, the energy source. With the open end like this is called the open switch. This is a closed switch, so you can see right now the switch is closed. And right here, this is a resistor. So this could be a light bulb, or it could be a buzzer, maybe it could be a bell, maybe it could be something that generates heat energy from the electrical. So it's just something that slows down, transforms electrical energy into another form of energy. So it wants you to draw this circuit diagram right here, down here, but it wants you to use this key right here. So I might start with the battery. The battery gets this symbol. Since the battery is going in this direction, then this symbol should be going up and down. The light bulb, the light bulb, the light bulb are all resistors, so they get this symbol right here. So you need one over here, two down here, and this switch is in the, that's right, open position, so you need a symbol of that right here, and then you need to connect everything with the wires. You can push pause if you need to catch up on that. Page number 149. Circuits are a way to convert electrical energy into other forms of energy. A circuit needs a source of energy. This is usually the battery. So here's another one. Circuits don't connect just to lights. Circuits can also connect to little bitty motors. Now we're turning the electrical energy in the battery over into a rotation right here that would be called, thank you, mechanical energy. Over here it's not giving off light energy. It's being turned into mechanical also, because this hammer right here is going to ding the bell, giving out vibration, giving out sound. So electrical energy can be converted into sound energy, it can be converted into mechanical energy and light energy. And of course it can also be converted into heat energy. An electromagnet. Ooh, I love electromagnets. We used to teach these, but then they decided to move it away from 5th grade, so now it's up in 6th or something. So we don't get to talk about these much, but they make a lot of sense. An electromagnet is a big, giant magnet, but it's not a natural magnet. It's a forced magnet. They force this metal to become magnetized using electricity, and that's why it's called an electromagnet. Electricity and magnetism are closely related. All electrical currents produce a magnetic field. Electromagnetics are magnets that use electrical current. They consist of a current that flows through a coiled wire connected to a circuit. The strength of an electromagnet can be increased by increasing the number of loops of wire, by increasing the current, or by wrapping the wire around a metal bar. Ordinary magnets are always magnetic, but electromagnetics are only magnetic when electric current is applied. That means you can turn this magnet off and on, and that's how these junkyards like this can use them, because if it was always magnetic, you'd never be able to get this stuff off here unless some guy crawled up here and started pulling all this metal off. That's probably not very safe. But since it's an electromagnet and it's got wires going to it, he can turn this off and all this metal stuff will just fall. And if he wants to pick up more, then he can turn this back on. So electromagnets can be very helpful. If you would like to write down something about that, you may. I'm not writing it down, so I don't plan on asking you any questions about it. Okay, some old guy, that's fine. We're going to skip these questions. Oh, look, here's some more cards to cut out. And we're on page number 157, so you can go ahead and cut out vibration, energy, the ability to do work, transparent. Let's get rid of kinetic energy. You do not need to know this one. I'm not going to ask you questions about it. Same for potential. I'm not going to use it. Translucent, some of the light comes through. Let's see if the next page has some cards you can cut out. Oh, look, there's more. The resistor, transform, opaque, no light can pass through, reflection, refraction, the conductor, the insulator, and electrical circuit. Yeah, those are good cards. You can cut those out, and you can add, oh, I got one. And you can add those to the baggie that you already have. I hope you're keeping up. I'll probably do a baggie check when I get back to make sure everybody has their baggie. Remember, there are extra cards here. So if there were some cards missing, or they didn't have some of these words on the card and you'd like to add them, do they have conductor and insulator? Let me go back. I can see. Yeah, I don't see conductor and insulator. So it'd be great if you would add a card for conductor. Is that the only extra card they have? But we had some extra cards the other day, and I bet in a little bit we'll have some more. Or you could always trim a card or just a regular piece of paper down to this size and do the same thing for insulator. You can push pause if you need some time, and when you're ready, we can continue. Page number 174. Man, we didn't write down a bunch about circuits, did we? Forces. A force is a push or a pull. Forces can be balanced or unbalanced. A balanced force means both sides are the same. They are balanced. For example, if two kids with the same amount of strength were playing tug of war, no one could really win because their force is balanced. An unbalanced force, the sides are not the same. One side is stronger than the other. And that would be an example of Mr. Haas playing tug of war with one of you. It would probably be unbalanced. Theoretically, I should win because I should have more force. So here's some about force. Baseball is great for force. We got forces all over the place. Look, his foot is pushing against the soil there. That's a force. The hat is the bat. Excuse me, not the hat. The bat. The bat is hitting the ball. That's a push or a pull. He's pushing that bat that way, so I think that's a push. He is throwing, or she is throwing the ball, or the person is throwing the ball. They're going to catch the ball, so we got pushes and pulls. We've got force going all over the place over here. Contact force. Well, let's see what this is. Car mechanics use forces to lift tires and pull tool carts. These forces cannot act unless the mechanic touches the object to be moved. The object may be touched directly with a hand or using a handle or a rope, but there must be contact. That means you have to touch it. A force that requires two pieces of matter to touch is called a contact force. I don't think we'll write that one down. We'll skip that one. Friction. We know about friction already. Friction is the force that results when two materials rub against each other. Friction, two materials rub against each other. Friction makes it harder for one surface to move past another. The amount of friction between two objects may depend on their texture, shape, speed, and weight. We've talked a lot about friction already, like how much friction you have on skates. If you're skating on cement, you don't have a lot of friction. I like to skate personally on carpet. I require a little bit more friction so I can skate more better. Ooh. Gravity. We're going to skip this other non-contact force. You're welcome to read about it. I'm not that interested in it. Gravity. Yeah. We need to talk about gravity. We just talked about that some the other week when we were talking about the moon's pull on the Earth's oceans. Gravity. Every object in the universe exerts a pull on every other object. This force of attraction between any two objects is called gravity. It's a force of attraction between objects. Only the gravity of a large object such as Earth is strong enough to cause effects that we can notice easily. Without gravity, things would not fall. Gravity pulls objects towards Earth's center without touching them. So gravity pulls objects towards Earth. The moon's gravity pulls Earth's oceans to high tide. The sun's gravity keeps the planets in orbit. We're going to talk about that some more when I get back, probably. Planets in orbit. But there's some examples of gravity. There's gravity on the moon, because when the astronauts landed on the moon, they were able to kind of walk around the moon. So the moon pulled on them some, but not as much as Earth pulls on them. That makes sense because the moon is a lot smaller. Electricity and electrical and magnetic forces. Electric forces act between objects that are electrically charged. Oh yeah. Such as static electricity. That's a force, because if you rub this comb through your hair several times and then get it close to these little fine pieces of paper, they're going to be attracted to it. And that's a pull. That's a force. A magnet is going to attract or pull or give a force on a piece of metal. So that's also a type of force. Okay, we finished that page. We skip that page. Changes in motion. Here's a big word. Acceleration. When an object speeds up or slows down or changes direction, its motion changes. The rate at which the speed or the direction or motion of an object changes over time is called acceleration. When we speak of acceleration, we usually mean going faster and faster. But in science, the word acceleration means any change in motion. For example, the circular motion of a Ferris wheel is accelerated. Even if the wheel turns with constant speed, the riders change direction all the time. They go up, then forward, then down, and then backward. So there's some information about acceleration. We're not going to study Newton's first law. You'll study these more in middle school. Newton's second law. And eventually there should be Newton's third law. You're welcome to read them. We're not going to study them in 5th grade, so we're good. Yep, there it is right there. This stuff is not for 5th graders. You're not required to know it for your 9 weeks assessments. We can skip that page. Good, we're done with that. Don't have to do that. Okay, then. Oh, the cards. The cards. Where are the cards? Oh, here they are. So page number 199. Oh, come on. You can cut out non-contact force. You don't have to really work on it. I'm not going to ask you about it. You should know force. You should know gravity. You should know friction. I'm not that big on acceleration, contact, or non-contact force. That'll be up to you. Skip that one. So if you need to push pause to finish cutting out those cards, you can go ahead and cut out those cards. I think I'm really good on this part of the video. Plus, I'm almost out of time right now. Yeah, this is a good stopping point. I will talk to you in a minute. Have a happy day.